All right, so I know that somebody requested that I do this because they knew they were going to be out, and I know that I already have some people that are out because they're on vacations and such. So we're going to knock this out, and we're going to continue to talk about motion graphs. And today we're going to look at 8 different graphs, and we're going to describe the motion, which really does fit our I can statement. And I have to flip back to that. I can identify the types of motion graphs, interpret the data in order to determine the motion of an object. Now, if we follow what we said is the number 1 rule, what's the first thing I should do before I start doing anything else, Stacy? I need to see what kind of graph this is, and I'll notice that this is a distance time graph. Do you see that? Distance time graph. Now, it's very helpful on these, at least, for some of us, to put numbers in here instead of just looking at a blank graph. So I'm going to do that really quickly. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Same thing going up. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if I look at this, I know that my second thing is look at the graph data and look at, do I need to plot anything? Well, it's already been plotted for me, right? But I'm going to put that into an XY table. Is distance on the x-axis or is time on the x-axis? I always get that confused, Zoe. Time. So if I label this is time is x and distance is y, and I start an XY table over here, and I go here, and I start, because I don't want to go in between, that makes it a little harder. I'm just going to where it actually meets points on the graph, and I'll notice I have 1, 1, 2, 2, 3, 3, and so forth. I'm going to stop at 6, 6, because I know it goes all the way up to 10, 10, but I don't have time to write all that out, nor enough space. And we need to talk about that. I look at this, and I know that there are definitely one thing that's going through my mind, because it's a misconception, and I need everyone to understand this is not a hill. This is not a graph of something going up a hill. Can you see how people think that? I most definitely understand why people think that this is a hill. It's not. It's not a hill. Now, if I start looking at all of this, and I know that I have distance, and I have time, there's a very specific thing I can find when I divide distance divided by time. If I do that, Jeremiah, what am I getting?
Speed.
I can find speed. So I'm going to see what the speed is of this object throughout the different parts of this graph. So again, distance divided by time. 1 divided by 1 is? 2 divided by 2 is? 1. Everybody says 2 today. I don't understand why. 2 divided by 2 is? 1. 3 divided by 3? 4 divided by 4? 5 divided by 5? And 6 divided by 6. And I could go all the way to 10 divided by 10 and still get 1. Every time I look at the graph, Jacob, I realize that this object is going 1. That could be 1 meter per second, 1 mile per second, 1 mile per minute. I don't know. It doesn't matter. I just know it's going 1. It's doing the same thing every time I check on it. What term would I use to describe that? When every time I look at the speed, Marielli, it's the exact same thing. What do we call that? It is constant speed. Now you can open your door. I'm going to have to write on top of this. This is constant speed. All right, so we're picking back up with the misconceptions of this. People want to look at this and they see this and they want to say, oh, that's something going up a hill. That's incorrect. This is not a hill. Not a hill. The second misconception that people make very often they think that this is acceleration. Because if I look at the speed one, it looks the same thing, doesn't it? They look exactly alike, minus this little detail over here. This would say speed. This one says distance. This is not acceleration. Not acceleration. So I have a motion graph. We decided by looking at all of the facts and all of the data that it is a constant speed. And we know that we are not going to get this confused with a hill. We are not going to get this confused with acceleration. All right, so now we're looking for you in your notebook on the top right. We're looking at the one that looks just like this. And so we are going to identify what type of graph it is. So that's the first thing I'm supposed to do. And Jacob, when I do that, I realize that this is a distance time graph. Many people, including people in this class, are going to benefit by drawing the numbers because it's going to help you see something. So I'm going to put the numbers in there really quickly. Got my origin at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm going to look at all of the data. Now, I know in the past we've actually plotted the data. The data's already plotted. So I need to put this into a table. And we're going to do the same thing that we did last time. We're going to have an X, Y table where we know that time is X and distance is Y. So let's look at 1. Where's it at? 4. Okay, so 1, 4. If I look at 2, I'm at 2, 4. If I look at 3, it's 3, 4, and 4, 4, and 5, 4. And I look all the way across. I'll stop at 6, but it stays at 4 the entire time. Now, Owen, I've got to ask you a question. If we were watching an object and it started on the 4th block, and every minute that went by it was still sitting on the 4th block, is that object moving? It's just sitting there. It's not in motion. And what do we call something that's not in motion, class?
At rest.
This object is at rest. That's what you need to be jotting on your paper under the little door flap. At rest. At rest. Now, when I look at this, Jasper, I can tell you, I can already start to see mistakes that people would make. Misconceptions about this one. Can you see them? What's the first one you see that someone might think about this? This is not a flat surface or a flat road. People see that all the time. What's another thing, Allie? It's not constant speed. That's what constant speed looks just like that. A constant speed on a speed time graph looks just like this graph, doesn't it? Exactly. Minus this little detail here, what type of graph it is. That's why it's important that we circle that to begin with. This is not constant speed. Not constant speed. Okay, I'm going to give people some time to jot some of this stuff down before I move on. I'm going to answer some of these questions around the room. Let me pause this guy here. Now again, if you're not careful, you can really goof up and you can make a big mistake. But if you do the number one thing and you check what type of graph is this, and you say, oh, I have a distance time graph. Boys and girls, this is the one you should not miss. There's only one curved graph that I have. Of all 8 that you have, it's the only one that's curved. Right? When you have distance and time and the line is curved, we looked at this yesterday, this is Whoa, don't want to write it in that font. That would be really wild. Acceleration. Acceleration. Now, the only thing that I've even heard that's remotely a misconception was somebody said they thought this was a skateboard ramp. I see the skateboard ramp. Yep, I see it. Somebody might think they're going up a sloped hill, I guess. Maybe. But that would be wrong, because if you're going faster, you're typically not going up a hill, right? Typically not going up a hill. Now, I do want to throw a little bit of a curveball at you, Maddie. If this is acceleration, what do you think this would be? It is. You might see this and it would be deceleration. I only say that because I saw that with either an EOG or a check-in, and there was some weird curved graph that was curved the opposite way, and I'm thinking, really? You put 0 questions on SchoolNet, nothing online about it, and then you're going to give us a question about it. I just don't think that that's fair. I really wasn't stressed about kids that missed that question because honestly and truthfully, that's such a random question that it doesn't even matter to me. I don't know where you are in your attention span at the moment, but I'm going to actually stop this video and start another one for this last one because this last one has taken about 20 minutes per class to explain. So I'm going to stop this. So see you in a minute on the next video if you're watching this.